Welcome back. The topic of today's project is question and answer telling chatbot. It's a very simple project and basically we will be doing some text comparisons, and this is the part 1. So in this part 1 video we will be learning about using NLTK, normalizing the corpus, that is text normalization. Last day we did the text normalization using some different methods. Today we will be purely working with NLTK, where we will be doing tokenization, then we will be definitely converting text to a common case. Then third, we'll be working on POS, that is parts of speech tagging, and finally lemmatization. So in this normalization process, these are the steps we will be following. And in the part 2, which will be next, I will be uploading, there will be actually the basic work. See, it is a very basic project for just understanding purpose. Our project, what we will be doing, there will be asking one question and in return we will get back a sentence as an answer, right, using similarity score. Now we will be focusing on NLTK library, we will be focusing on scikit-learn or sklearn library, and TF-IDF vectorizer we will be using. With this, we will be using some more features that I will introduce it in the next tutorial. So today we will keep it very simple till normalization. So let's jump to our project. Okay, so let's start with our coding part. So as we will be using NLTK for this whole process of this part 1 tutorial, here we will be actually working with normalization. So here you need to first install NLTK library. So I have written pip install NLTK, and here already I have installed, that's why requirement already satisfied. So if you have not installed, simply you will be installing this. Otherwise, if you directly write or type import NLTK, then you will get an error. Simple. So once we have imported our NLTK library, first work we need the sample on which we will be doing normalization process. So we can call it as a small corpus. So here I am just writing a simple sentence to keep our project simple. So this is a simple project. You can make it more diversified, but for now let it be very simple. So now text variable is containing a simple word. It can be a single word. It can be more than one sentence, more than one sentence. Now in the first part, in the first step of normalization, we need to do tokenization. Now for this we need to download nltk.download punkt. So punkt is a module in NLTK that will help us doing the tokenization. Now you saw a message, the pink one. So you will find it like this because I have already downloaded, I didn't download here. Now for this nltk.word tokenize, the text where we have kept this sentence, we will be working on this. Now see, in sentence token, the string has been converted to a list of strings. That is, it has divided or it has broken each word and made it different string. So this is our first part. Now once we have done tokenization, we have broken down this tokens to one. Token is the one word simple. Now second step is not lemmatization, but to understand a bit nicely, I am doing this lemmatization first, then I will do the POS tagging. Now for lemmatization also you need to download NLTK download WordNet. So WordNet will help you, and this is the message what you will get. So from NLTK stem we are importing WordNet lemmatizer. So this is a class. Now we will be making a instance. We will be creating one instance of WordNet lemmatizer class. So lemmatizer is our object or instance. With this we will work. So before we proceed with our work, let's understand a simple example. So it is a very common example because we know that lemmatization is actually bringing those words to its base form. Now if I write, if I type W1 equal to is and W2 equal to was, this is a very common example. So according to normal English, that is W1, if I write equal to W2, if I compare, it will show us that the answer is false. But when we do, or when we see the lemma of these two words, we will find something different. So how to write this? So first, lemma 1 equal to lemmatizer dot lemmatize. So we are lemmatizing one word. So I have just pressed shift tab by clicking on lemmatize. Okay, so I got this. So here it is saying it requires an argument, one string word, and the second one is POS, means parts of speech tag. So here I have included this V. V stands for verb. Okay, now I have done it for is. Now let me copy and paste, and for was, let's see what is the lemma of is and what is the lemma of was. So why we are actually doing this? Because the words, see here it appeared as B for both of these, means their base, their root is same. From there it has been used as is, was for the English literature, but here to do our analysis more simplified way, the text analysis, we are using this lemma. Okay, so we need to bring down to the base form, or we say it as dictionary form, so that we can do the simplified work. Now see, this is the signature and we will be working on this. Now these tokens are many, but here as per the syntax only one word is allowed and only POS of that single word is allowed. But we have our list of words. For that we need to do some different thing. So before we do something else, let's do the POS tagging, because we need two arguments. One is word and the second one is the POS tag of that word. So before we jump to lemmatization, after tokenization we need to do POS tagging. Fine. Now for this, if you get an error, whatever error it is showing, you just download it and the error is gone. So I am not doing it here because here I will not find any error. So now see, I have written NLTK.POS tag. Now sent underscore token, that I am providing it as an argument. Now after I run this shell, what I get, that a list of tuples. Tuples in has one element, means one tuple has, see here it has the word and the POS tagging. Now we need this POS underscore tags. Okay, now for reference purpose I am just keeping it as it. So see, this is the first part, this is the second part, and we have now these two arguments ready in our hand. Now we can do the lemmatization part. So when we will doing the lemmatization, we need a list to keep or to append all these things. So for that I have just taken an empty list, that is sent underscore lemma. Now we will be working with the for loop, but we will be getting two elements for token and for the POS. So we need to use this function, zip function. So we use zip function to access two or more iterables. So we have two or more iterables because send token is a list, and the second iterable from where we will get, that is POS underscore tags. See, we have in every go we have this tuple. So this is also an iterable. So what I want to show here, that each element of the list has the second part, and from that second part the first letter we need. So how to do that? So we will be extracting. How to extract? Let's first do it, then we will again go for the next step. So let's print it. So first, from the send tokens, we'll simply get the token, and for this one, the second part, the first element we will get. From the first element, she, this word is in the 0 number index, PRP in the first number of index. So for POS tag we need the first index, and the first index is 0, because there are 3 letters: 0, index number 0, 1 and then 2. And once we get that value, or sorry, that letter character, we are using on that the lower function. Now see, it is matching with our this one, whatever we have kept in front for just seeing purpose. Now somewhere you can see that full stop is there, see. So this is actually not anything related to POS tag. So we need to do something for this also. So till this we are clear that actually what we are extracting and how to extract. Now all the POS tags actually we don't want, so we need to do one if condition. We have to perform this. So if that V or P, whatever is in these, we are actually using this noun, verb and these 4 tags, adjective and adverb. So actually for our we are actually doing here sentence comparisons, or in a better way we can say we are actually doing the primary, we are comparing the sentence or the word. So we need these 4 POS for our simple analysis. Okay, so now this is simple. The first, when we saw this example lematizer, we lematize that example part, we have understood this. Now the third part is we are just appending it. Each time the for loop does the lemmatization, it keeps on appending to this sent lemma, that is a list. Now see, once I run this, we got the lemma. So now you can compare that. In our actual sentence there are more tokens, but the one which we need are now here. So we did for the normalization process tokenization, then we did the POS tagging, now lemmatization. Now I think this is a very simple flow, and now I will just put it together. So we can put it together using a function. So first what we will do, first according to our process flow, we will be putting this tokenization part. So this is our first part of normalization. Once we send the text, so the actions which will be flowing one by one, I am keeping those things one by one. So first tokenization, then POS tagging, and third this lemmatization part. Now it is easy to understand. You can say that it is a sort of pipeline we are building. So this function will do all these 3 things once the text is sent to it. Now for this, whatever the required things, I am just putting it together. So here import NLTK is necessary, and secondly these 2 lines, that wordnet we need to make the instance, and this is also necessary. So this is something in a whole, and once everything is done, the 3 part of normalization is done, we will be returning the lemmatized that list. Okay, now let's call our function. So our function is sent match, means sentence match, and inside this we will put as the argument our this example. So let's directly put this one inside this function. Now let's execute it. Now see, it called the function, it lemmatized, and we got in return the lemmatized sentence. Now we will be just experimenting it with this, and this process, this logic we will be using in our part 2, where we will be learning more few basic things that will actually eventually help us in making our chatbot. So this is the part 1, where we provided the text corpus, where we did the normalization with NLTK using very simple method, and we understood with a few example things also. So this is it for today. I hope this helped you. We will meet in the next part. So subscribe my channel and get notified.